Good evening, everyone. My name is May Welcher, and I'd like to welcome you back to another Tech Talk in our series sponsored by Bracklet. Today, we have the pleasure of welcoming William Dalessandro to give us a brief talk about TensorFlow. So without further ado, I'd like to pass it on over to you, William.
Thank you for that, May. Hello, my name is William Dalessandro, or Billy Jack as most know me. And before I start, I would like to thank Bracklet for sponsoring this Tech Talk. So tonight, I'm happy to give a brief presentation on TensorFlow. So to clearly structure this information on TensorFlow, I would like to center this presentation around the 5 basic W's. What is TensorFlow? Who created it? When should it be used? Where is it used? Why should we use it? And so on. Keeping this structure in mind, it should be easy to retain some of the information presented here. So to start off, what is TensorFlow? TensorFlow, to describe it extremely simply, is just a library for performing mathematical calculations. However, its range and breadth is so wide that the more accurate description would be an end-to-end platform for machine learning development. This means that it handles everything from pre-processing data to creating and training AI models and even production deployment of these trained models. On top of it having the ability to be an end-to-end tool, TensorFlow can be used across various platforms like desktops, servers, microcontrollers, mobile devices, and so on, enabling AI to live in all of these places. Now, closely associated with TensorFlow is Keras. I won't be getting too deep into it tonight, but what it is an open source library that provides high-level building blocks for creating deep learning models. Essentially, its job is to make TensorFlow easier to use. So now that we know what TensorFlow is, let's talk about who created it. Created by the Google Brain team in November 9th, 2015, it gained its foundation from Disbelief, which was a machine learning system focused on neural networks. Disbelief started to be used all across Google, and Jeff Dean, shown here on the left, was tasked to simplify and refactor the codebase into a faster and more robust library, which later became TensorFlow. Later, in 2009, a team led by Geoffrey Hinton, shown here on the right, implemented backpropagation, a machine learning technique that helps improve the accuracy of neural networks by training them to correct errors. This method was revolutionary and essentially shot the entire AI industry onto the trajectory it has today. Jeff Dean eventually became Google's head of AI, and Geoffrey Hinton earned many accolades and rewards for his contributions to AI, and has earned the nickname the Godfather of Deep Learning. And lastly, over here, in 2019, Google released TensorFlow 2.0 in response to other competitors in the space, attempting to make TensorFlow easier to use and more efficient. So when do we use TensorFlow? Well, as an end-to-end platform for machine learning, it is used at every step of AI integration. You can use it at step 1 for handling your data. TensorFlow gives you multiple tools for preparing and loading data, setting you and your project up for success. However, maybe you want to skip cleaning data because that can be a drag. You can just start at step 2 over here and use standard data sets that TensorFlow provides to instantly start fine-tuning your models. Now, perhaps you've already established a model elsewhere, but you'd want to run it on your TI-84 calculator, or maybe some other device with limited resources. For this, you can slide in at step 3 and use TensorFlow Lite, which is a framework designed by TensorFlow, to run your models almost anywhere. And lastly, perhaps you have it all set up already and would like to improve it or automate your AI deployment workflow. TensorFlow has you covered. You can use TFX or TensorFlow Extended to accomplish this and more. And quick note, I don't think you can run TensorFlow on your TI-84, but would be cool, maybe. So why TensorFlow? There are other very popular AI frameworks in the wild, and while all seem to be great tech, they each have their own pros and cons. So TensorFlow, shown here, its pros. It's production ready, scalable, and it integrates well with other Google services and cloud platforms. The cons, on the other hand, is that it has a steep learning curve that's difficult for beginners. Now, shown here is PyTorch. PyTorch is a popular competitor to TensorFlow developed by Meta AI, and it comes with its own pros and cons. It's reportedly easier to use and favored by researchers. Researchers favor this because they work in environments where rapid prototyping and experimentation is important. Now, the cons is that it's not as efficient for large-scale projects, and it doesn't have the same maturity as TensorFlow, which has been around for almost 10 years. So where is TensorFlow used? It's used globally in all sectors of tech, used in academia, and it's used in famous companies such as Spotify. They use it to help build their song recommendation algorithm and their AI DJs. Coca-Cola and Airbnb, they use TensorFlow for OCR, which are just deep learning models that can detect objects and images and classify these images. And then Visco, shown here, uses TensorFlow Lite for their AI features that suggest relevant photo editing presets for the user. So now let's talk about how TensorFlow works. The steps laid out here will hold true for nearly any work you do with an AI model. First, you prepare your dataset. Next, you define your model. After that, you compile it with optimizer and loss functions, train it, evaluate the results, and then deploy it. There are countless ways to use TensorFlow, but I'd like to go over how you could use it to implement a simple AI for binary classification. A classic example of binary classification is something that could look at a picture of food and determine if it's hot dog or not hot dog. But more appropriately, I will walk through the creation and training of an AI that I created last night that has the ability to find out if a website is a phishing website or not. And for those who don't know, phishing websites are nefarious websites that often look like legitimate websites and are used to trick people into entering sensitive information. So here we could see some code and some of the features. On the right-hand side, we look at and we prepare our data. So this data here is a collection of 30 features from various websites that describe their URL lengths, IP address, HTTP statuses, etc. This data is here to help the model find connections between these seemingly random parameters and whether a website is a phishing website or not. So you can see here, we have IP address assigned this value 1, URL length 1, and what we want our AI to do is to find these patterns between this. So on line 100, we load the data up that's given in this format, and then we take this and define the type of model we want to feed it into. Line 107 here shows a sequential model, and we're doing this model because we're using binary classification. From there, we create 3 layers for our data to propagate through. On line 116, we compile our model with an optimizer and a loss function. This essentially means we're equipping it with the tools it needs in order to learn. The optimizer lets it learn efficiently, and the loss model makes sure it learns from its mistakes. Next, on line 123, we begin training our model. And later, the next slide, I'll show a portion of code that prints out the diagrams you can use to track how training with the model went. So here the results on the left-hand side show the final status of our now trained model, and below it we can see the progress of the training. Zoom in here. So these graphs are wildly useful since the loss and accuracy curves here verify that our model was converging onto a correct high-level evaluation, one that was giving 97.96% accuracy. And you can see here the training progress as we've gone through more iterations, passing our data through, the loss eventually went lower and lower. Next, on the right-hand side, I took the now trained model and saved it so that I could evaluate URLs that weren't included in the training or testing data. You can see over here, Google came out as normal when I evaluated it. But then something like www.goo.gl.com was classified as fishy. Since it looks very close to the normal address, however, it's not exactly that. So lastly, to recap, here's too long, don't read for further future reference. 1. Who created TensorFlow? Google Brain did in 2015. What is TensorFlow? Well, it's an end-to-end platform for AI development. When do we use it? Well, we use it at literally any point in the AI dev pipeline. Where is it used? It's used at Google, Spotify, Airbnb, etc. Why TensorFlow over others? It's production ready, strong community, and it's been around for a very long time. And how to use it? You grab your data, choose your model, train it, and enjoy your results. The last step is have fun with it. Here are my works cited. And thank you all for listening. I'd like to open the floor for any questions. All right, if there are no questions, my contact info is shown here, and feel free to reach out for anything. And lastly, I'd like to thank Bracklet once again for sponsoring this Tech Talk. And now I'll pass it back to you, May.
Thank you so much for that informative talk, Billy Jack. And thank you everyone for coming out tonight. We'll see you at the next one.